Salam and welcome everyone. So today we're going to be working on the question on the screen that says, given the reactions 1 and 2 below, determine the change in enthalpy of reaction as well as the change in internal energy of reaction for reactions 3. All reactions occur at 298 kelvins. So the first thing you have to note is this. Equation 1 is given to us, equation 2 is given to us, and equation 3 is given to us. So the reaction equation for 1, 2, and 3 are given to us. But we are asked to only determine the change in enthalpy for reaction 3. This is because we already have the change in enthalpy of reaction for equation 1 to be 52.96 kilojoule per mole, as well as the change in enthalpy of reaction for equation 2, which is negative 483.64 kilojoule per mole. The first thing you have to do is for you to observe, because what we're going to be using here to solve this question is called HESS law, or some people call it HESS's law. I'm not exactly sure, whatever you want to call it, just basically understand the law. What HESS's law does is we're going to manipulate the first two equation in such a way that we're going to get the third equation, right? It's like we need 4i, sorry, it's like this. We need to determine the equation 4HI gas plus O2 gas would give us or would produce 2I2 solid plus 2H2O gas. So we have to manipulate equation 1 and equation 2 in such a way that when we work with both equations, we're going to get equation 3. It's like simultaneous equation, right? So if you remember that in your middle school as well as in high school as well, you would notice that we have to manipulate it, meaning from a simultaneous equation, which is the technique we're going to be applying here. You see that we're going to have to cancel out some stuff. We're going to have to multiply some stuff. We're going to have to do, we're going to have to switch both sides of the equation. We're going to have to multiply through by negative or multiply, sorry, we're going to have to multiply through by negative. Things like that is basically what we're going to be doing here. So the first thing we do is I'm going to rewrite the equation 3. So equation 3 here, we have 4HI, okay, plus O2 gas. So gas here as well would give you 2I2 solid plus 2H2O gas, right? Well, if you look at equation 1 and equation 2, you'll see that 2HI exists in equation 1, but it's on the right side of the equation. So what we have to do now is for equation 1, okay, remember 3 is what we're trying to get. So we're going to be using it to know how to manipulate equation 1 and 2. So for equation 1, switch both sides of the equation. Okay, of equation. So what's not going to happen is that we're going to end up with 2HI. Okay, let me use a red marker for equations. So we're going to have 2HI instead, gas. Okay, would actually give us H2 gas plus I2 solid. And of course, anytime you switch equations mathematically, we're gonna is the same thing as multiplying by -1. So now the updated change in enthalpy of reaction is going to be the updated change in enthalpy of reaction is gonna be -1 times 52.96 kilojoule per mole. So what we end up with is -52.96 kilojoule per mole. So that is the first manipulation. Now we have to reconnect and look at it again. What do we see? We see basically that the HI that we're dealing with here is 4HI. And then for equation 1, we have 2HI. So the next instruction is going to be for you to multiply equation 1, okay, by 2. When we multiply equation 1 by 2, this 2HI is going to become 4HI. So we're going to end up with 4HI. So gas will now give us, okay, 2H2 gas, okay, plus 2I2 solid. And when you look at our work, you're going to see thus far, we have been able to successfully um, get what is on the left side of the equation, right? This information here to match equation 1. So equation 3 matches equation 1 for the molecule for each high gas, and then it also matches the molecule to I2 solid, and it also matches the direction. So it's both on the product side for equation 1 and equation 2. So this is good. So now all we have to focus on is on oxygen gas as well as 2H2O gas. So the next thing is we have to look at equation 2. How do we manipulate equation 2 to look like equation 3? Well, from what we have here, we don't need to do any form of manipulation because the O2 for equation because the O2 gas for equation 3 matches the O2 gas for equation 3, right? So the O2 gas for equation 3 matches the O2 gas for equation 2. So these two match. And then the 2H2O gas matches that of equation for both equations match. So the H2H2O gas for equation 3 or reaction 3 matches the 2H2O gas for reaction 2. So basically this is okay. But before we go ahead, let's not forget that um for equation 1, even though we've multiplied by 2, we don't just leave the enthalpy of reaction just like that. We have to now multiply the enthalpy of reaction that we have, negative 52.96 by 2. So that's going to be changing enthalpy of reaction. Since we multiplied it by 2 for the equation, we have to do the same thing for the number value. So that will be negative 105.92 kilojoule per mole. So this is basically how you solve this question. Now, we have equation 1, okay, and we have equation 2. So writing the information, let's rewrite equation 1 and equation 2. So equation 1 is now 4HI, okay, gas, so 2H2 gas, okay, plus 2I2 solid. And then equation 2 remains the same. We're not multiplying by anything. We're not switching both sides. It's going to remain the same. So we just have 2H2 gas. I hope you guys are understanding it so far. If you don't understand it, there's no issue. All you have to do is just like try to rewatch this video again. So 2H2 gas plus O2 gas is going to give us 2H2O gas. So now basically this is what you get. So anytime you have a situation, I've underlined 2H2, where a molecule in particular is appearing on both reactions on opposite sides of the equation, you have to take a good look at them. So you have a situation where in equation 1, 2H2 gas is on the product side, and then in equation 2, 2H2 gas is on the reactant side. That means they basically oppose each other. So all you have to do is just cancel them out. And hence you can now write your updated reaction for 3. So it's basically rewriting it. So what you end up with is 4HI, okay, gas, plus this O2 right here, O2 gas, would give you 2I2 solid plus 2H2O gas. So this is basically the answer. And when you look at equation 3, what we were asked to solve for, we successfully solved for it. So that is number 3. So we're able to determine the equation. Now you're going to notice that um I still haven't answered the question, change in enthalpy of reaction. Well, it's easy. The manipulations you did in equation 1 and equation 2 to find new equations. So, for example, now for change in enthalpy of a reaction for equation 1, we have 105.92 kilojoule per mole. And then changing enthalpy of reaction for equation 2, we have the same exact thing. It did not change because we did not manipulate the equation in any way. So it's still going to be negative 483.64 kilojoule per mole. So negative 483.64 kilojoule per mole. So that's basically what it is. So you're now going to be wondering, okay, so what happens, right, to the enthalpy of reaction? Well, all you have to do is just simply add them up. So it's going to be 105 enthalpy of reaction for equation 3 becomes adding enthalpy of reaction for equation 1 and then to equation 2. Okay. 105.92 kilojoule per mole plus negative 483.64 kilojoule per mole. So when you add them up, what you end up with changing enthalpy of reaction is going to be, oops, I almost missed something. Actually, rewriting this, I forgot to add the negative. So for reaction 1 is negative 105. So it's going to be negative 105. Sorry for the mistake. Imagine doing all this work just so you skip a minus sign. Please make sure you always look at your work. Even me as your tutor, I always have to cross check my work. So when you do this, you end up putting this information in the calculator to get negative 589.56 kilojoule per mole. And this is basically the answer to this question. So I wanted to mention that the work is not actually done because the second part of our question asks us to find the change in internal energy of reaction. And I'm going to be doing it in another video because I feel like this information for HESS's law can be a lot. So make sure you watch the video in the description box. So if you have any questions based on Hess's law and how we determined the change in enthalpy of reaction, make sure you put that in the comment section. If you have questions about other um, things related to STEM, make sure you also put it in the comment section. If you have concerns and suggestions, please put it in the comment section. I also wanted to mention that if you're a student who's trying to succeed in all your STEM related courses, I am the tutor for you because I help students who are trying to succeed in their STEM related courses, whether they're in middle school, high school, and college level, to basically reach your potential. If you would like mentorship as well as coaching in relation to academia, make sure you email me at shohabitutoring@gmail.com. If you just want a simple tutoring class or a group tutoring class, make sure you also email me at shohabitutoring@gmail.com. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.